Anyone working in Pro AV generally knows the 50-foot rule.
Oh, absolutely.
Yeah, you push an uncompressed 4K HDMI signal past that, and you are basically asking for severe signal degradation, or just, a completely dead black screen.
It's a total nightmare.
Right. So, welcome to this custom deep dive where we are looking into the exact invisible infrastructure that solves this for massive smart spaces.
We've got the spec sheet for the Kramer EXT3-POE-XR-R receiver today.
Very catchy name, I know. But our mission for you is to decode how this hardware pulls off some really serious heavy lifting behind the scenes. And, we're going to do it without getting totally bogged down in the technical jargon.
Right, because if you look at a sprawling corporate conference center, or maybe like a massive sports bar, the central video matrix, the primary hub routing all of those signals, could be a literal football field away from the actual display.
Yeah, standard cables just hit a physical wall there.
Exactly. Which brings us to this Kramer receiver's core superpower.
Right, the distance problem. It uses HDTV to extend uncompressed 4K video at 60 Hz.
Plus a full gigabit of Ethernet, USB 2.0, and remote control signals.
And it pushes all of that up to 330 feet over standard C-Cat copper cable. I mean, it's essentially acting as a digital teleporter.
That's a great way to put it.
Like, instead of just blasting a massive fragile video signal down the line, it disassembles the data stream at the atomic level, right? Shoots those microscopic digital chunks down the twisted pairs inside the CAT cable simultaneously, and then flawlessly reassembles them 330 feet away.
Yeah, that packetization is really the only way to manage that kind of bandwidth without relying on super delicate fiber optics. Uncompressed 4K video is just a monstrous data load on its own.
Oh, for sure.
Combine that with up to 32 channels of uncompressed digital signals for, like, studio-grade surround sound. Historically, you'd need a really thick, expensive bundle of specialized cables.
But HDTV 3.0 turns a single twisted pair copper wire into a high-speed superhighway.
Right, by perfectly synchronizing those data packets.
Okay, let's unpack this a bit, though. Pushing data 330 feet is one thing, but copper at that distance comes with severe voltage drop.
Oh yeah, the power problem.
Right. So if you have a wall plate display at the far end of that run without a local electrical outlet, you can't just expect standard power over Ethernet to push enough steady wattage through that tiny straw without some active management.
No, the system has to dynamically negotiate the voltage on the fly. And that's where bidirectional PoE comes in.
Bidirectional power over Ethernet.
Exactly. The Kramer receiver has this active auto-sensing capability. It monitors the line status in real time to determine the required power flow direction.
Okay, wait, so it's a two-way street for electricity?
Essentially, yeah.
It senses whether it needs to provide power down the copper line to a remote endpoint, or if it needs to reverse course and accept power drawn from an upstream provider matrix. That is wild.
It is. And what's fascinating here is that it negotiates that power delivery seamlessly to prevent underpowering or, completely frying the connected devices.
Because you're combining massive data and variable power on the exact same copper pairs over a massive distance.
Right, which usually introduces a super high potential for handshake failures.
Whoa, ENIDed.
Yeah.
Extended display identification data.
You got it. When you connect a screen and a video source, they exchange EDID.
The display basically hands the source its resume, right? Saying, here are the exact resolutions and refresh rates I can handle.
Precisely. And if you're routing power in 4K video through 300 feet of networking cable, keeping that EDID exchange perfectly synced sounds like a total networking nightmare.
Yeah, handshake failures are the leading cause of those dreaded signal not supported errors in commercial setups.
But Kramer tackles this with what they call intelligent EDID processing, or iEDID Pro.
So it's the brains of the operation.
It really is. It intercepts and actively manages that entire data exchange.
It functions almost like a universal translator, instantly negotiating the technical specs between the source matrix and the display locally.
Yeah, caching the EDID so the source always sees a valid active display.
Making the whole system plug and play despite that huge physical gap.
And it does all this heavy lifting silently. The receiver is built into what Kramer calls a Mega Tools enclosure.
Right, I saw that. It's totally fanless.
Exactly. It has no mechanical fans, relies entirely on convection cooling, so it can just be tucked away up in a drop ceiling, doing its job completely invisibly.
Just a silent little aluminum box making the magic happen. And looking at the sources, it currently sits at a discounted price of $772.
Which is pretty incredible for what it does.
Yeah, at that tier, it's not just a basic receiver. It is the critical invisible infrastructure making these modern smart spaces actually possible.
It is the silent bridge keeping the whole ecosystem reliably connected end to end.
So we'll leave you with this provocative thought to mull over today. As single cable share highways increasingly carry our highest quality data and our power simultaneously across these massive distances,
Yeah.
are we approaching a future where traditional electrical outlets become entirely obsolete? Something for you to think about next time you see a crisp 4K screen floating perfectly on a stadium wall.